alternating series and conditional convergence. What's an alternating series? Alternating series is when the terms are positive and negative, okay? Or if you want to see it in terms of the partial sums, partial sums is gonna be like to the right and to the left of L. Look, S1 is here, S2 is here, S3 is here, because of it becomes positive and negative, positive and negative. S3 is to the right and S4 is to the left. Okay? If we have such a series which is alternating, which means it is positive, negative, positive, negative, positive, negative, how am I gonna decide whether this is convergent or not? And this theorem actually answers that. So it says that this alternating series is going to be convergent if the following conditions are satisfied. First of all, these UNs are all positive. We want to make sure. And UNs are eventually non-increasing, which means they have to go down. They have to decrease after some n. And then this UN has to go to 0. Okay? If you have all these satisfied, then this series is going to be convergent. It's going to have a finite limit. Okay. The harmonic series diverges, but we have an alternating harmonic series. It is convergent. Okay. What's a harmonic series? Harmonic series is 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6. So this is our harmonic series. We call it harmonic series. But we have an alternating harmonic series. This harmonic series is divergent. Okay? It's going to go up, up, up. You won't be able to stop it. Okay? The partial sums, they increase eventually. They get bigger. You cannot make it stop, so it is divergent. However, if you look at the alternating harmonic series, which means 1 minus 1 over 2, look, 1 minus 1 over 2 plus 1 over 3 minus 1 over 4 plus 1 over 5. So this is actually acting nicer. So we look at the partial sums. Partial sums is 1, then this, then this, then this, then this, then this. And see, it's going to be around natural log of 2. So 0.693, close to that. So although the harmonic series is divergent, alternating harmonic series is not divergent. It's convergent. Okay, we skip this. Okay, there's a terminology. Sometimes a series converges but doesn't converge absolutely. Okay, doesn't converge absolutely. Okay, we call this series converges conditionally. That's the terminology. Okay. So let's say we have an absolutely convergent series. We wanna there's a theorem which is rearrangement theorem for absolutely convergent series. Let's say we know a series is convergent absolutely, and let's say B1, B2, Bn is any rearrangement of the sequence An, then this new rearrangement is gonna converge absolutely as well. So that's a really good property. But this works only for absolutely convergent series. Okay. This is a, let's see. Yeah, this is a summary. The n-term test for divergence. The n-term test for divergence, we just look at the An, the sequence An. It has to go to 0. If it doesn't go to 0, then the series is divergent for sure. We have the geometric series. We have seen sum a r to the n. It's going to be convergent if the absolute value of r less than 1, otherwise it diverges. We had a p series which is similar to the p series for the integrals as well. Sum of 1 over n to the p convergent is convergent if p is greater than 1, otherwise it diverges. How about series with non-negative terms? If you have a series with non-negative terms, you can try integral test, you can try comparison test. You can try limit comparison test, you can try ratio test, you can try root test, you can try all these if you know that the series has non-negative terms. Series with some negative terms, you can apply the absolute, you can check whether it's absolutely convergent or not. If it's absolutely convergent, then you're good. So consider the sum of the absolute value of an and apply the ratio test, root test to it, or any test that we said in step 4. And if you get it right, if it is convergent, then we are going to call it absolutely convergent. So any series that's absolutely convergent, it's convergent itself, so we are done. An alternating series, for alternating series we have a list of conditions. If these conditions are satisfied, then sum of an is going to be convergent. We have this alternating series test.